In this video, I will be explaining you the first proposition that you can see the second unit of measure and integration. Okay, so here you can see the statement. Okay, we are going to prove one by one. This is the first one, this is the second one. You have to prove all these. So let's see. So here first we have to read the statement. That is very important, right? Let the following f. They are given you a function f. Okay. F have a measurable domain E. That is, f is on the measurable set E. Okay. That is what they mean by that sentence. Then the following statements are equivalent. What you have to prove? You have to say these statements are equivalent. So we know that if they ask you to prove the given statement are equivalent means what? We have to prove what? 1 implies 2, 2 implies 3, 3 implies 4 and 4 implies 1. Right? That is what we have to prove, right? So that is what we are going to do here also. Okay. This is the first statement, this is the second one, this is the third one, this is the fourth one. So first we are going to prove 1 implies 2. What is mean by 1 implies 2? It means you are assuming the first statement. By assuming the first statement, you will prove the second one. And then what you will do? You will assume the second statement and you will prove the third one. Right? That is what you will do. So here first start with the first one, that is 1 implies 2. So here what you are doing is you are assuming the first statement given. That is, you are assuming this. Assume. Okay. Set of all x belongs to E such that f of x greater than C is measurable. Just copy it down from the question. And then to prove the second statement, right? That is, our second statement is this. X belongs to E such that f of x greater than or equal to C is measurable. That is what we have to prove. So to prove this, what you are doing is, you are considering first, considering this. That is, considering the set that is given in the to prove. Okay. Okay, just copy it down, consider by writing consider and write this is equal to this can be written like this. Okay, this and this gives you the same meaning. Okay, this set can be written like this, and there you are not going to get any variation. You are writing the same set but in a different format. That is what they mean by this. So this can be written like this. You have to know how they are writing this. You should not forget this. So that I have wrote all these things in the reading, because we have to recall it again and again. Then only we don't forget this. So here you are writing this like this. Okay, after writing this, you have to write something. Okay, that's not difficult. If you can remember this, then you can write this proof of this theorem in a very good manner. Okay, so you have to write like this. This can be written as intersection n is equal to 1 to infinitive. Set of all x belongs to such that, write this f of x. If there is greater than or equal to, then you have to put here greater than C minus 1 by n. Okay, greater than C minus 1 by n. After writing like that, what you have to do is, from the assumption, you can say x belongs to E such that f of x greater than C minus 1 by n is measurable. Therefore, if this is measurable, then with this, when you find the intersection of this, that will also be measurable. Therefore, if the whole thing is measurable, then you can say the left hand side also measurable. Therefore, that you have proved what they asked us to prove. Okay. Similarly, you are proving for the second implies 3, 3 implies 4 and 4 implies 1. So here I am not going to explain you more like how I have explained you for 1 implies 2. Okay, in short I will say, because I hope that you understood what is there in the statement. So you are doing the same thing for each part. So now you are doing second implies, sorry, 2 implies 3. So you are assuming the second one and you will prove the third. So just take the take this by writing consider. Okay, consider and take this, and this can be written like this. Okay, if there is greater than or equal to, then you have to just put greater than. If there is a less than without equal to, then you have to write like this. You have to write here is less than, here you have to put greater than or equal to. See the whole complement. Okay, just fix in your mind that what is the difference. Okay, be clear in that. Similarly, you are proving 3 implies 4, the same thing you have to do, and for 4 implies 1 also the same thing. Only thing what you have to do is the thing that I have wrote with reading, you should not forget that. So you have to avoid forgetting this, what you have to do is we have to recall it again and again. Okay, then only we don't forget this. So I will show you the proof, because sometimes you might be in need of the proof, right? So I will show you. You can make use of it. Okay, if you really need this, you can use of it, hence the proof.